All right, and we're moving. Let's turn off this so we have less glare. And let's turn this on. Okay. Now, last week we were working on perimeter and area. So let's look at the key formulas for perimeter and area. So perimeter is, well, let's see. Let's just do area for a rectangle. Is equal to length times width. And then the area of a circle is equal to pi r squared. And then the circumference, which is the distance around the circle, is equal to 2 pi r. And then on the exam, they will either want pi in the answer, or they'll tell you what value of pi to use. And we said that the most common values for pi that they would ask you to use is pi is equal to 3.14, or pi is equal to 22/7. Okay. Now, sometimes what they'll do is they'll want you to use the Pythagorean theorem. So let's put this up here. And this will only work for right triangles. Okay. So when we mean right triangles, we're talking about triangles where one side is a right angle, something that's 90 degrees, something that's a perfect L. So let's okay. So first, let's do the Pythagorean theorem, and then we'll use a Pythagorean, and then we'll find the area of triangles, and then we'll do sort of composites of these. Okay. So let's look at something like find A. So we're going to assume that's a right triangle. We're going to assume that this is 3. We're going to call this A, and then we're going to call this 5. Okay. And the Pythagorean theorem is a squared plus b squared is equal to c squared. So let's call this B, and let's call this C. Okay. So go ahead and fill in the blanks and solve that. Okay. And if you can't, I'll do it in a second. So let's just look at the computation of this. Okay. So we're saying that A squared is equal to 3 squared is equal to 5 squared. So that's A squared is equal to, I'm sorry, it's plus, sorry about that. Plus 9 is equal to 25. And then if I subtract 9 from both sides, I get a squared is equal to 16. And then in order to find what a is, I square root both sides. Now, normally when you square root both sides, you add a plus or a minus. The reason why we don't add a plus or minus is because a is a distance. So for example, if I was to ask you, how tall are you? You would say something like, oh, I'm 5'8" or I'm 5'4". You wouldn't say I am -5'8" or -5'4", right? If I asked you, how far do you live from LA Valley College? You would say 2 miles. You would not say -2 miles. So whenever we're talking about a distance, it's always positive. So if I asked you, how long is this line here? You would say 4 inches. You wouldn't say -4 inches. So now we have a is equal to 4, right? Just positive. Okay, so let me change the cartridge in my pen. That's getting a little light. Go ahead, copy the board. Okay, that's better. Now let's start talking about the names of the different pieces, because they may not give you a actual triangle, they may describe it. Okay, so this right here is called the hypotenuse. Okay, it's the longest side. Now sometimes they'll say that this is the side opposite the right angle. Opposite means that it doesn't touch the right angle. So this is the side that does not touch the right angle. Now the two sides that do touch the right angle are called legs. So this right here is a leg, and this right here is a leg. Okay. Now it doesn't matter whether this is A and this is B, or this is B and this is A. It doesn't matter. Okay. In terms of this formula. So either of these can be A or B. Okay. So let me give you an example where they don't mention the where they don't mention or don't show draw a figure of a graph. So they can say,
can
go
I
ahead.
ask you a question?
Please.
Why you calling that right angle? It's on the left, that little square, right? You're talking
Oh,
about.
okay. Good question. So a right angle isn't which side it is. A right angle is when this right here is 90 degrees. So 90 degrees, so a right angle equals to a 90-degree angle. So think of it as a perfect L, right? So it's a perfect L. At that that shape is a right angle. Okay. So it doesn't matter whether it looks like that or if it looks like this. And we'll denote it with a little square like that. Is that better?
Yes, thank you.
Okay, thanks for your question. Okay, so find the hypotenuse. Oh, find the length of the hypotenuse find the length of the hypotenuse if of a right triangle if the legs are length 6 and 10. Well, let's make it 6 and 7. Okay. So try doing that. So this can be A or this can be A. It doesn't matter which one is A, as long as one of these is A and one of these is B. But you just have to be careful about the hypotenuse, because the hypotenuse is always B. C. Okay, so let's take a look at this. So the triangle that we're working off of, right? It doesn't matter whether it's pointing this way or that way, is 6, 7, and C. Okay. So now we have A squared plus B squared is equal to C squared. And then we have 6 squared plus 49 plus 7 squared is equal to C squared. So 36 plus 49 is equal to, let's see what that is.
85.
85? Thank you. So is 85. Okay. Now let's see if we can simplify that. Yeah. Okay. All right. So we're going to square root both sides. So C will be equal to square root of 85. Okay. Now let me give you another one. Okay. So let me give it to you like this. Okay, so go ahead, do that.
Professor,
Mhm.
Professor, this is
Yes.
this C also equal to square 85?
Say that again.
This X equal to square 85, same as previous one.
Not quite, almost. So I'll show you the trick on this one in a second.
Okay.
All right, there's a little trick to this. Okay, so let's look at this. So we have, we'll make this one A, this one B, and then this one C. Okay. Now remember that the formula is A squared plus B squared is equal to C squared. What we don't know, oh, you're right, this is. Oh, shoot, I gave you you're right, I'm wrong. I wanted to give you something else. So this is 81 is equal to X squared. And then let's square root both sides. Oh, 85. Okay, I apologize. You're right. Let me give you a different one. I wanted to give you something else. So let's give you this one right here. Okay. So let's give you something that looks like this. Okay. Let's make this 8. Let's make this 7. Let's make this X, and let me go find X. And you'll know to use a Pythagorean theorem because they have, it'll be a right triangle. You'll see a little square there.
Professor, X equal to square root 15.
Okay. Remember what we're talking about, right? Don't
Okay,
you
I
know the
remember.
answer?
Okay, thank you.
All right. Okay. So let's take a look at this. So what's going on is we have A, B, and then the difference between this one and the other ones is that C is now the hypotenuse. So the formula is A squared plus B squared is equal to C squared. So we know 7 squared and we know 8 squared, and it's really B squared that we don't know. Okay. So that's the one you have to be careful about. Usually this is the one students mess up. So we go 49. Okay. And then let's subtract the 49 from both sides. So we get B squared is equal to 15. And then let's square root both sides. Like that. Okay. So if you go, 1 second. So let's now look at the area of a triangle. So an area of a triangle is 1/2 base times height. Okay. Now I apologize, my phone for some reason is not working, so I can't send you slides, but I will be able to send you the video to today's lecture.
Professor, I have a question, Professor.
Sure, please.
Professor, you say is this is 1/2 times this B is
A base.
base this 1/2 times B times base times height.
Mhm. We're going to go over this in a second, but yes. Yes. Okay. Is that better? So I'll explain what base is, and I'll explain what height is in a second. But does that help with your question yet?
Yes.
Okay, all right, thank you. Oh, I should probably put the formula here. A, B, C, A squared plus B squared is equal to C squared. Okay. Now, when we have a triangle, okay, I'm going to give you a bunch of different triangles. So I have a triangle here. Okay. So there's a couple of rules. Okay. Base is equal to one side of the triangle. Okay. So if I had a base for this triangle, this would be my base right here. It's one side. Any of the sides could be a base, but just know that it is equal to one side of the triangle. Okay. Now the height and base form a right angle. Okay, so this right here would be my base, right? They form a right angle. Okay. And then the height is the farthest distance the line that the base is on. Okay. So go ahead, copy that. So very weird sentence. Okay. So I want you to see that this is my base, and the point furthest from the base, right, from the line the base is on, is that point over here. That's why that's my height. Now, the other one that is fairly intuitive is if I have something like this, okay, My base is one side. And the point furthest from this, that is a right angle, is this right here. So this is my height. Okay. So most students are comfortable with this and this. Okay. Where they have trouble with is this one right here. Okay, so now this will be my base. This length right here, because the base is only the length of one side of the triangle. Now, if we extend this side, okay, so we're talking about the line that the side is in. What is the point furthest away from this line that creates a right angle? And that would be over here. So this distance here would be my height. Okay. Now, there's a couple ways they'll try to fool you on the test. One is to give you too many numbers. So let's try something like this. Okay. And let's try making this one 10. Let's try making this one 8. Let's try making this one 6. Let's make this one 4. And let's make this 1. And then let's say find area. Okay. Now we're talking about area of the solid triangle, not the one with the dotted. Okay, so let's take a look at this. So my base is going to be here. My height is going to be here because I have this rectangle. So now this is going to be 1/2, right? Area is equal to 1/2 8 times 4 is equal to 16. Okay. Now let's try another one. Okay. Now sometimes they'll try to disorient you by making the triangle upside down, sideways, or diagonal. Okay. So this right here is 10, 3, 2, 7. Okay, give that one a shot. Okay. So this is the base. This is the height. So now we're looking at 1/2 2 times 10, which is equal to 10. Okay. Now let's see how we can how this can be used further in combination with the Pythagorean theorem. So let's say they give you this problem. Okay. So they're not asking you for X. They're asking you for the area and perimeter. But in order to find the area and perimeter, you need to find the length of this right here. So go ahead and use Pythagorean theorem to find this length, and then go ahead and find the area and perimeter.
Professor,
Mhm.
Professor, I have a question. This one, you look at this, 5 you put here is a my question is, my English is not strong. My question is, you 5 put there can either A or B, whatever. I can put
That'll
A.
be, yeah, 5 will be A or B, and 13 will be the C.
Okay, 13 must C, but 5 is either A or B, but C must 13, must 13.
Yeah.
Okay.
Okay. Okay, so let's look at this. So we want to know what X is. Without knowing X, we can't know what the area and perimeter is. Okay, so even though they didn't make it look like a Pythagorean theorem problem, it's a Pythagorean theorem problem. So we have, we'll call this A, We'll call this B, and then we'll call this C. Okay. So we have A squared plus B squared is equal to C squared. And we get 5 squared plus B squared is equal to 13 squared. So B squared is equal to, well, 25 plus B squared is equal to 169. Yeah. Okay. So we get B squared is equal to 144. And then let's square root both sides.
B equal to 12.
B will be equal to 12. Okay, so that's 12. So if we look at the perimeter, this will be 5 plus 13 plus 12 is equal to 20. And if we look at the area, okay, we can make this the base and we can make this the height. So the area is equal to 1/2. 5 times 12 is equal to 30.
Isn't
Okay.
isn't the perimeter 30 as well?
Is it 30? Oh, I think so. Let's see. 25, you're right, 30. Thank you for adding correctly. Because I'm bad at it. Okay, now let's do another one similar to this. And I've seen this one on TEAS exams also.
So Professor, for you to go through all these steps, if they give you if they give you A and C, but not the base, this is the only time you will go through all of this, right? But if
Well,
you do
they'll probably ask
height,
you one question. They can ask you what is X. They can ask you what the perimeter is, or they can ask you the area. I doubt they'll ask you all three. So I don't think they'll ask you to do, so it's usually this one or this one.
got it. Thank you.
Yeah, but I don't think they'll ask you for both. So they like to disguise questions. Like they know that when you see this, you go Pythagorean theorem, but if they go find the area, you kind of freak out. So that's what they're trying to do is say, can we separate the people who understand that if I find this, I have the area? So I think they'll ask either this or that. Or if they want to make this the easy question, they could ask you this. Okay. But another one that I've seen is something that looks like this right here. So we'll go find the area and perimeter. And then usually it'll be a word problem and they describe it as like a stained glass window. Okay. And this will be, let's say 10. Let's say this is 8. And then they'll say this is 3. Okay. So either they ask you the area of the stained glass window or they ask you for the perimeter. Okay. Now, what you want to see is that you have 2 right triangles here. Okay. Now, even though they don't write, so what you want to see it as this. Where this is 8, this is 10, this is 4, this is 4, this is 3, and this is 3. So even though they don't tell you that this is, let me get rid of that so it looks better. Okay, so even though they don't tell you that that this part is 4 and this part is 4, you're supposed to assume it because it's half of 8. Okay. The other way they could write it is they could draw it like this to further hide that this is a right triangle if you cut it in half. Okay. So go ahead and solve this problem. You want to find this and this, right? They'll be the same. So find x and x, and then find the perimeter and find the area. Well, actually, let me take that back. The problem will more likely look like this one here. Because you can find the area if you have 3, 4, 8, and 10 and 8. You don't need this one to find the area. So it'll more look like this. Let's make that 5. Okay, so go ahead and do that now. Okay, so make this part here 5. Okay, so let's take a look at this. So over here, we want to find what x is. So we have a squared plus b squared is equal to c squared. And we're going to have this equal to c, this is equal to a, and this is going to be b. So we have 4 squared plus 5 x squared is equal to 5 squared. So 16 plus x squared is equal to 25. And then you subtract 16, and we get x squared is equal to 9, and then you square root. That. Okay. So now we have this is equal to 3. Okay. So I have this large triangle. You can treat it as a small triangle. That's fine. I'm going to treat it as a large triangle. And this is going to be 3. And my area is going to be 1/2. 3 times 8 is equal to 12. And then the area of the rectangle. So this is the area of the triangle. And the area of the rectangle is equal to 8 times 10, 80. So when I add these up, I get total area is equal to 92. Now, the other thing we can have is when we find the perimeter, well, let's fill this out. It's going to be, oops, that's 10. 10 plus 8 plus 10, right? This, 5, 5. Plus 5 plus 5, and that's equal to 38. Okay. Okay, let me give everyone a second with that. Okay, now here are some area only problems that look sort of scarier. They're a little bit scarier than they are. Okay, so let's do up to here. Okay, there's a little trick to them. So let's say I have something that looks like this. Oops. Okay, we're going to erase that. And we're going to say,
I have a question, Professor.
sure, please.
Professor, this one, the previous one, I asked the previous one. Previous one, your area in area is just the triangle area and the I don't know how to say
Rectangle?
rectangle.
Uh-huh.
Rectangle and
Yes. So you're saying it correctly.
but the
So
area
it's this area plus this area.
if we find area is have to both is both area up one and bottom one.
Yes.
And the total.
So we want the area of both of them. Yes.
How you got how much is this area?
Okay. So the area for this one. So this one is 3 And this right here is 8.
Yeah, area you got a 12. Yes.
12, yes, okay. And then this one is 8. I'm sorry, 8.
Uh-huh.
And then this part is 10.
80.
So then
That's 80.
80, yeah. Then
80.
when we add them together, that's what we get.
Oh, okay. Got it.
Is that better?
Thank you. Thank you. Thank you.
No problem, no problem. Okay. So let's try and do this one. So this one here is this one here, let's make this one 10. So what I want you to do is I want you to find the area and the perimeter. Okay, now think of this as a square. So this is 10, 10, 10 all the way around. Okay. Oh, I guess we shouldn't call it perimeter because it's it has a curve in it. Perimeter is only for straight lines. So we'll find the distance around the shape. Okay. Okay. Now for area, we're used to adding things, right? In this past one, we said, oh, the area is this shape plus that shape. But we can also do subtraction. We can do this area is equal to the area of the rectangle minus the area of the half circle. And we know that this is 10, and we know this is 10, and we know that this is 5.
Professor.
Uh-huh. Yeah.
I'm sorry. I interfere you. I have a question. I'm confused right now. A little bit. Is the previous one? Previously one uses perimeter is 10 plus 8 plus 10 plus both 5. Which one? The 5? Where is the 5 coming from?
Okay, so we go. So it looks like this.
Uh-huh.
And then we have 10. I'm sorry. We have 8, 10,
Uh-huh.
10.
Uh-huh.
And then this is 5 and this is 5. So we got this one from doing the Pythagorean theorem. Remember we had it like this, right? This one was 3, this one is 4, and this was x.
Yes.
And then we said 3 squared plus 4 squared is equal to x squared. So 9 plus 16 is equal to x squared.
Uh-huh.
And 25 is equal to x squared.
I didn't get this one. I didn't get this one. You said 10 plus 8 plus 10 plus this both are 5 plus 5
Yeah.
plus 5.
Yeah. So we originally had given you this as the problem. Like this. And then we were able to say that, oh, okay, this is 2 right triangles, and this is going to be 4 and 4. And then this is going to be 3, right? So now I have this right triangle.
But we got
And
is equal to is 3. 4 and 3. It means 4 and 3. That side is 5. Yes, we got another side is 5. When you plus 2 times 5, 10 plus 8 plus 10.
I have 5 here and I have 5 here. So 10, 8, 10, 5, 5.
But I didn't get this one, Professor. I'm confused here. I'm
Okay,
confused.
so okay, so let's go back to it, okay? So let's say I have something that looks like like this. Okay. So are you okay that
Professor.
Yeah.
I got.
you got it
I
now?
got. How. I got 5. I got. Thank you.
Okay, all right, thank you. And then thank you for your questions. Okay. So in terms of area, what we want to do here is we can also do subtraction. We can say I have this shape minus this shape. So go ahead and figure out what the area of the square is, and then subtract the area of the semicircle. Okay. So this will be 10 squared minus 1/2 so half a circle is 1/2 pi 5 squared. So this is 100 minus 25 divided by 2 times pi. And then they may want you to convert to pi, but we won't worry about that right now. Okay. Now go ahead and find the distance around the shape. So we know it's 10, 10, 10, and then this is going to be half the circumference. Right? So 10, 10, 10. So what you want to do is find the distance of half of the circumference.
Professor,
Mhm.
I have a question. You said
Sure.
this 100 minus this one, 25 over 2 times pi. Why you minus?
Well, this whole shape would be 100, right? But this is smaller, right? Because we cut out this half a circle.
Yes.
So it has to be this minus the area of that, because it's less this portion.
Okay.
Do you see how the area here is smaller than this one? So it's this much less.
Okay.
Okay. It's half a circle left.
100 minus 25 over 2 times pi, that is the total area.
Yeah. Yeah.
Okay.
All right. So we'll go area here. Okay. All right. Now, so the distance around the shape is equal to 10 plus 10 plus 10 plus half the circumference. Okay. So it's equal to 30 plus 1/2 2 pi, and then r is going to be 5. So it's going to be 30. Oops, I'm sorry. Yeah, 30 plus 30 plus 5 pi. 5 pi, yeah. Okay, let's do one last one, and then we'll move on to another topic. Okay, and then the homework, I'm going to give you some of these. Okay. So let me give you a square. Let's make this 9, and then let me give you a circle in it. 2. Okay. Find the area. Find the area of the shaded region.
Professor,
Mhm.
I have a
Yes.
question. Use this
Sure.
5, the previous one. Previous one is a half circle. This 5 is radius, not the diameter. Is
Yes, yeah, 5 is the radius.
okay. Thank you.
We know that 5 is the radius because one side of this, right, is 10. So half of this will be 5. Like that.
Thank you, God. Thank you.
Okay, you got it?
Use
Okay,
this
thank
one.
you.
This one, you inside the circle, the radius, how much? 2 or 3?
The radius is, say that again?
It's inside this small inside the circle. Circle is inside.
Mhm.
What the radius you put how much?
2.
Oh, 2. Thank you.
Mhm. Okay, let's take a look at this. So this is going to be equal to the area is going to be equal to the total area, the area of the rectangle minus the area of the circle. So it's 9 squared minus pi 2 squared, right? R squared. So it's equal to 81 minus 4 pi. Okay. Okay, so that's good. Let me give everyone a second to copy that, and you'll have homework problems to work on this. I sent you a whole bunch of files. I have a few better worksheets. So I wasn't sure quite what we were going to work on today. So I will send you homework and the video. After the video's ready, usually takes a few hours for it to be ready and for it to get uploaded on YouTube. Okay, so wait for homework. I'll send it to you in a separate email. Now, that being said, if you can go to the files I sent you. Okay, and let's see, which one do we want to look at? Let's look at the, let's see, how much time do we have? Okay, let's look at the average rate of change. So I sent you a worksheet that says average rate of change. If you can't find it, let me put it in the chat. So give me 1 second.
It's 16 pages, right?
Yeah, but we're only gonna do the first 10.
Okay.
All right, so if you're like a little overwhelmed, like a lot of that is not on the test. Okay, so let me find it. Give me 1 second. There we go. All right, I'm gonna put it in the chat. Boom. So let's just look at the first 10 questions. Let me get to the right place also. Oh. Actually, let me, yeah, so for this one, we're gonna work on problems. Oh, this one is not 1 through 10. I'll have to figure out what numbers we're gonna work on. Give me 1 second though. Yeah, so let's start with problem. I'm getting a little confused with this. G, H, and
Because
X.
Professor, you send a lot homework.
I know, give me a second. We're not doing all of them. We're just doing some. I'm just getting a little, give me 1 second to, there we go, okay. Now, all right, so let's look at problem 95. Yeah, problem 95. Let me share screen with you.
Professor, if you make us work in this rate, you're gonna make us professor like you are.
Okay, good. I just want you to like pass this test and then never look at math again. That's my goal.
Thank you.
Okay. Okay. So is it taking you guys too long to do homework? Because if it is, I can lower it a little bit.
Yes.
It is, it's taking a long time. Okay. Let's look at this right here. So what I can do is I could try to make it more specific so it's not so time consuming. Okay. But it should take a few hours a week, especially the percent stuff. Okay. Now, when we look at this, I just want you to know that rate of change is the same thing as slope. So all the things that went along with slope, where you had rate of change is equal to slope. So that's also equal to y2 minus y1 all over x2 minus x1, like that. Okay, so that's one idea, okay, is that these formulas also work. The other ideas are that this, oops, that's way too big, is that if I'm drawing something from left to right, this has a positive slope. Okay. And
Sorry
then
to interrupt, Professor.
go ahead.
We did the practice exam, and this is one of the questions that it was there, and it's been a while the last time I've done this, and it was really tricky to just figure it out.
Okay, good. So you did see this, right?
Yes.
Okay, good. All right, good. I'm glad we're doing this. So this is negative slope. Okay. Now they don't call it slope. They call it rate of change. Rate of change and slope are exactly the same thing. Okay. Now, when trying to compare whether one has a bigger slope than the other, the red line has a bigger slope. The reason why is that it points up steeper. So let's see. So the steeper line has bigger slope. Okay, so here are all the basic ideas behind rate of change. Okay, so remember, rate of change and slope mean the same thing. So if I'm pointing up, I have a positive slope. If I'm pointing down, I have a negative slope. And the steeper it is, right, the faster it goes up, the bigger slope it is. So over here is asking you the greatest rate of change. It's asking you which line is pointing up the highest. So if we were to sort of look at this, right? So each one of these are exactly the same, right? From here to here, or from here to here, or from here to here, or from here to here, and then here. Okay. You want to say which one, right, has the steepest line? And that one would be
0 to 1 hour.
0 to 1 hour, right? And we could see that this line right here is going up the fastest. We can see over here, it's not going up at all. Okay, so that's how you tell, just like really quickly, which one has the steepest slope if they just give you a bunch of lines.
This was on the test too, Professor. Thank you.
It was on the test. Okay, good.
Yeah.
All right. So let's look at another one. So let me move all this stuff up. So bring this up here. Well, I'll clear everything. Okay. Okay. So figure out which one has the which one went up the most. Which one has the largest slope? Now, sometimes when you do the eyeball test, it's not very easy to tell. Now, I know definitely it's either this one or it's going to be this one. Right? One or the other. So what you can do is you can do the slope is equal
Subtract
to which one?
Subtract the big smaller number from the big one, right?
Well, remember that, okay, so you got to be really careful on this one. This one's a little bit different, right? The reason why is that this one is between 1 hour and 2 hour, and this one is between 6 hour and 8 hour. So this is over a 2 hour span, and this is over a 1 hour span. So you actually on this one have to use this formula. In the previous one, everything was 1 hour apart. So you could just count the Y's. But in this one, sometimes I'm 1 hour apart, sometimes I'm 2 hours apart. So you want to use this formula. But you can kind of say like, hey, when I look at this one, I know it's not this one, I know it's not that one, and I know it's not that one, because they look too flat. So if I just look at this red one and I go 110 minus 40 divided by 2 minus 1, I get 70. Okay. Now, if I look at this blue one over here, I get 350 minus 230, all divided by 8 minus 6. So now I get 120 divided by 2, and that'll be equal to 60. So you have to like recognize that if all the lines are exactly the same distance apart, then you can just look at the y2 minus y1 because the bottom is the same. But because this bottom is shorter than that bottom, you have to actually do the whole slope formula. So in this case, the solution is going to be this one right here. Okay. Is everyone comfortable with what just happened?
Yes.
Yes.
You're comfortable? Okay. All right. So let's go to the next one. Okay. Now they may give you a graph, or they can give you a table. So here's your X value, here's your Y value. Okay. So they want you to find the average rate of change from 20 to 80. Okay. So you're going to do the so this one over here will be your x1 y1. Oh, sorry, x2 y2, right? Because they're the bigger numbers. And then this one over here will be your x1 y1. It doesn't really matter whether you made this one x1 y1 or this one x2 y2, you'd still get the same answer. Okay, so even though they give you a table, check for what the starting value is and what the ending value is, and they want the slope in between those 2 points. So this will be m is equal to y2 minus y1 all over x2 minus x1. So we're looking at 2.3 minus 4.7 all divided by
Professor, that's 20, not 2 point. No, 2.3. What is 2.3?
oh down here.
Okay, got it. Thank you.
You got it? Okay. So this should be equal to negative 0.04. So the trick on this one is that they're trying to freak you out by giving you a whole bunch of numbers that you're ignoring.
Will that trick typically work for on graphs like this?
Yep. They'll either give you a table or a graph, and that's all we're doing.
Yeah, I saw 2 of those on the practice test too.
Okay, good. So
As
now
long
we
as-
can knock these out, right?
As long as you have your X and your Y's, right? You
Yep.
both of those.
Can we pick any like 20 and then after that 30 and then do this?
No, we can't. The reason why is down over here. So you got to be real careful because they'll give you a starting and ending value. So if we look at this down here, see how it
Because
says,
it's asking for average, right?
yeah, but remember, average over what range? The reason why we picked 20 and 80 is because it said 20 and 80.
Oh, okay.
Okay. So if we look at the
I
previous
have a question,
ones-
Professor.
Uh-huh.
I'm sorry, I have a question. Is it
Sure.
uses 20 minus 80 minus 20 卡度 20 20 minus 80 4.7 minus 2.3?
Yeah, you'll get the same answer.
Oh, okay, got it.
Okay. So if we look at our previous problems, so let's look at the previous problems. They're asking you first hour to second hour, here to here. Second hour to fourth hour, here to here. But if they wanted to, be tricky, they could ask you from first hour to 6th hour and then 6th hour to 10th hour. So be really careful because they're always going to give you a starting value and an ending value. Okay. So all the problems up till now was just, oh, go to the next one, go to the next one, go to the next one. But they may try to trick you by saying, go to this one and then go to one in the middle, one at the end. Okay, so let's try another one. Okay, so try this one.
Professor, we try 98 or 99?
98. Okay. Now, looking at this, it's not really clear whether they want me to start from this one or start from this one, right? Because they said that he enlarged it 4 times. So wouldn't full size be 1 or is it 0? Okay. Now, one way you can sort of check yourself is that the area of a 3x5 photograph is going to be 3 times 5. So 3 times 5 is equal to 15. So we're going to start with this one right here. And then we're going to end at that one. Okay. So usually when you have a table that is horizontal, X is on top and Y is on the bottom. So we have average rate of change is equal to 36.6 minus 15 all over 4 minus 0. And that gives us 5.4. Okay, so let's clear this one. Okay, let's just do one more. Okay, let's go back to a graph one. So go ahead, try this one right here with the graph. Okay. Now, definitely it's not this one. Oops, sorry. Definitely it's not this one. Huh. Let me try that again. Okay. Definitely it's not this one, and it's definitely not this one. And they did not ask for 1.5 to 2.5. So we're not looking at this one. So we're only looking at 2 of these. We're only looking at either here to here, or we're looking at here to here. Okay. So let's look at the red one first.
Professor, you said why definitely not last these 2? Yeah, why?
The 2, oh, because see how these are flatter,
Oh, got.
right? So we have to figure out which. So this middle one they didn't ask for, but these are flatter, so I know definitely they're not the biggest ones. So I can save time by just not doing it. I just have to worry about these 2. Okay. So let's do this first one. So are you okay with that one?
Yes, thank you.
Okay. So I think over here this is 200. So 700 minus 200 divided by 1 minus 0. So that's going to be equal to 600. So that's the red one here. So for the blue one, that's gonna be,
That's 500. What is 600? What's 600 coming? 700 minus
oh, 500, you're right. It's 500. Thank you.
Question is where is the 200 coming from? You said
Oh, over here.
Huh?
So this point right
Oh,
here.
Okay.
All right, so I'm assuming that this point over here is 200 comma, I'm sorry, 0 comma 200, like that. Okay, so I just have to read it off the graph. So when I go over here, I have 900 minus 700, all divided by 0.5. Well, okay, I'll go 1.5 minus 1. So this is 400. So this one is bigger. So that is my 0 to 1 hour is bigger. Okay, so I'll give you some of these problems to try. Does anyone need more time to copy?
No.
No, you guys are okay? Okay, so let's stop sharing this one. Okay, now the next one I want to look at, let me look at what I sent you. So we didn't cover everything, which is okay. We'll cover the rest of this next week. Okay, let's look at mean, median, and mode. Wait, do we want to do that? No, let's look at distribution shape. Okay, so let me share a screen. So let's look at this one here. This is distribution shape worksheet. Okay. Now, the words I would care about the most are symmetric, skewed left, unimodal, bimodal, outliers. I think those are the ones you want to care about the most. Okay. So symmetric means that the left and the right side are roughly equal. Make this a little smaller. Okay, and then let's move this over here. Okay. So of everything over here, this one is symmetric. And this one is symmetric. All right. Left and right side are roughly equal. Now, unimodal means that there's only one peak. Bimodal means that there are two peaks. They don't have to be equal in size. Multimodal has more than one peak. Okay. So figure out which ones of here are unimodal, which ones are bimodal. So let's see.
Is 4 of them unimodal, one is bimodal?
I think I would call this one bimodal. It doesn't have to have the same height. So I would consider both of these bimodal.
Okay,
I would consider this one unimodal. This one unimodal. And this one unimodal. Okay. Now, the other one that I think is really important that shows up a lot is skewed left and skewed right, because it works against your better judgment. Okay. This one here is skewed right. So I have most of my people are on the left side. I don't know why that's skewed right, but we have one bump and it's kind of like the bump is pushed to the right. Okay. This one over here is skewed left. Like that. Okay. Now, other words they would maybe use is something like normal distribution. So over here where I have something that is unimodal, symmetric, it kind of has one little bump. That's called a normal distribution. Another word for that is bell shape. Now, let's say this curve kept going out here, and you had a small bump that looked like this right here. So here's my distribution, and then I have one or two people way out over here. Okay. This thing that is completely separated, right, where you have a unique one or two people, not a group. See how this is a group? I wouldn't call that an outlier. This person over here is considered an outlier. Someone that's very different from everyone else. Okay. So if you have a group over here, we wouldn't call it an outlier. The most you could do is maybe call this is say that there is a gap. So, did you, they're gonna, I think most of the time they ask you like one problem that has vocabulary. Did you get statistics vocabulary on your exams?
Yeah, there was like 3 questions.
Were there any other words other than these words?
Yeah, they ask still left, still right, like a bell shape, like that.
Like this one?
Mhm.
Skewed right, skewed left, and bell shape?
Yeah.
Okay. Okay, does anyone need more time to copy? Okay, so let's clear this. Let me remind myself. Okay, so let's try doing these problems. Let's see, how much time do we have? We have 10 minutes. Okay, that's about the right amount of time. All right. So next week we'll go over more questions, but I know that students, let me kind of show you something that I sent you. I know a lot of students forgot what correlation and covariance is. So we will go over that next week. Okay. And then we'll do a little cleanup on a lot of little subjects. Okay. So go ahead and try doing this problem number 7. You don't have to explain your process. Now you can't get the exact number because these are not sort of tick marked off, but there are roughly 3 people in the red. And roughly, let's call it 9 people in the fuchsia, and roughly 20 people in the yellow, roughly 40 people in the green, and roughly let's say 21 people in the purple. So the best you could do in this graph is estimate. So the number of students who filled this out would be 81, 90, 93, roughly 93. Okay, so I'm just counting how many are in each block.
I have a question, Professor.
Sure.
You said red is 3, 9, 21, 40. Okay, got it.
Okay,
Thank you.
you're just looking at the y value here, at the height.
Thank you, got it.
Okay, and then let's try doing this one. In terms of forget the SOCS, I'm not sure what that stands for. Just use all the words that we had previously used before. Okay, so the lowest price is 50 cents. Right, because it's the lowest price. And then $4 is the highest.
Professor, $4 is highest where? I
Oh,
didn't
right
get-
here. You see how,
I think that's lowest.
oh, this is highest.
Why you say that's highest?
Well, what's cheaper, 50 cents
Uh-huh.
or $4?
Okay.
Okay, so remember, you have to read the what they say on the bar. This is price, right? So this is $4 and then that's 50 cents. This over here is how many cards people bought.
Okay, got it.
Okay. So this would be bimodal or yeah, bimodal. And you could say that there is a gap.
And 2 peaks.
And which one? Yeah, yeah. So the 2 peaks would be bimodal. And I think that's it. I don't think this is not symmetric. I don't think this is skewed right because you have a little gap over here. I think that's about it. Okay, thanks everyone. I'll see you next week. We'll do one more of these. Okay, so hang in there, everyone.
Thank you so much, Professor.
Okay, take care.
Professor, could you tell us then homework which one should we do, which one we